Apportionment, a fundamental mathematical concept in democracy, determines the fair allocation of legislative seats among regions of constituents. Employing methodologies like the Hamilton method, mathematics strives to ensure equitable representation for diverse populations. And by employing these mathematical formulas, we endeavor to uphold the principle of one person, one vote, fostering the essence of democracy by striving for fair and just representation for all. And that is why it is of utmost importance to include apportionment in the curriculum for mathematics and tertiary education because we want our students to better appreciate and practice their right to vote and in turn democracy.
So, good morning, everyone. I am your MMW instructor, Mr. Kevin Ryan R. Calderon, LPT. We are joined today by our assistant professor as I am facing some connection issues. So, I am currently at the top of Mount Everest. My helicopter crashed here as I was traveling to Nepal for a conference.
Anyway, good morning everyone. My name is Miss Via Jassen Laroa and I will be assisting Sir Kevin for today. Today's topic is about apportionment. Does anyone in class know what apportionment is or has heard the term? Okay, I see. Well, that's why today we're all going to learn about it. Please watch this short clip to tell you the real life application of apportionment in the United States of America.
How does apportionment work? The method of equal proportions is used to distribute the 435 seats in the U.S. House of Representatives among the 50 states based on their population. This ensures that each congressional district has roughly the same number of people to represent.
Now that we know apportionment is widely used during government functions, it comes as no surprise that over time, there have been countless methods that have been developed for doing so. That is the nature of human evolution to adapt, innovate, and learn.
Now, going back, let us discuss one of the methods of apportionment, Hamilton's method. It's quite simple, really. The first step would be determine how many people each representative should represent. You can do this by dividing the total population of the states by the total number of representatives. The answer would be called the standard divisor or simply the divisor. Step 2. Divide each state's population by the divisor in order to determine how many representatives it should have. Record this answer in several decimal places. This answer would be called the quota.
So since we can only allocate whole representatives, Hamilton resolves the whole number problem as follows. So for step 3, cut off the decimal parts of all the quotas, but don't forget what the decimals were. These are called the lower quotas. So remember that class, lower quotas. Then we add the lower quotas. This sum will always be less than or equal to the total number of representatives. And for the fourth and last step, assuming that the total step from step 3 was less than the total number of representatives, assign the remaining representatives, one each, to the states whose decimal parts of the quota were largest, until the desired total is reached. Make sure that each state ends up with at least one representative.
So now for our sample problem. Let's imagine a scenario where the Philippine government tries to distribute 100 seats to the representatives of the three main islands, Luzon, Visayas, and Mindanao. The representative count, please Sir Kevin, write this on the table. For Luzon is 643, Visayas 372, and Mindanao 504.
Wait a second. For Mindanao, what was it?
504.
Thank you, Miss Laroa. Let me share my screen again. So if we add 643, 372, and 504, what will be the total population for the representatives of the three main islands?
Grace?
So what's the answer, Miss Grace?
I got 1519, sir.
1519. That's correct. So what's the use of this number, 1519? We will use that to get the standard divisor. We can get the standard divisor by dividing 1519 by the number of C's, which is 100. So 1519 divided by 100. Who can give me the answer?
Mr. Elrich?
It's 15.19, miss.
Thank you for that wonderful answer. So now that we have the standard divisor, we will divide each population of the three main islands by 15.19. So 643 divided by 15.19. Who can give me the answer?
Katriel?
That would be 42.3304, sir.
Good. So for Visayas, the same thing. Who can give me the answer?
Elrich?
It's 24.4897, miss.
And lastly, for Mindanao, who could give me the
Chris?
The answer would be 33.1797, sir.
Good. So if we add all of this, we will get a total number of approximately 100. So for the initial, what we will do for the initial column is to remove the decimal parts of each quotas. So who can give me the whole value of
I
each?
saw Miss Carmel raising her hand since earlier.
It is 42, 24, and 33 respectively.
Good. So if we add 42, 24, and 33, we'll only get 99. There's an extra seat left. So Miss Laroa, can you assist me what we are going to do if there's an extra seat?
So remember, class, when we have to allocate extra seats, we must observe which of the quotas has the largest decimal part. And after observing the data presented by Sir Kevin, which do you think would receive the extra seat? Anyone? Oh, Elrich.
It would be Visayas, miss.
Excellent. So now we will have the final allocated seats for Luzon is 42, for Visayas is 25, and for Mindanao is 33. And which is, we will get a total of 100. So that's it for example problem number 1. And I hope you learned something from me, class.
Oh, okay, wait. I'll be contacting Sir Kevin shortly. I think he disconnected because he's staying at Mount Everest, and I hope he's fine. And I'm going to contact the emergency personnel near the hotel he's staying. Settle down, class. Let's disregard that for a short while. I'll be contacting them. Going back to the topic at hand, the Hamilton method, despite being very understandable and all, is not entirely perfect. It has been subject to some paradoxes, such as the Alabama paradox, the new states paradox, and the population paradox. This is one of the reasons why, over time, people have created new methods